Okay, so welcome everybody to this session. So the first so before beginning today's topics, so the topics today would be mostly problem based. I mean, I would be solving some problems, but before doing that, let me I was asked by somebody last class about 3 questions about from your assignments this semester. So if I am not mistaken, I hope the person is here. I am not sure who had asked me.
Yes, sir.
Yeah, okay. So you had asked question 4 and 7 from assignment 1 and question 11 from assignment 2. Is that correct?
Yes, sir.
Okay, so I got hold of the assignments, so let me open that. I mean, you won't be seeing that, so I'll just read it out. So assignment 1, question 4. So the question goes something like, which of the following statements describes what is most likely true when the amount of training data increases? So the question is, training data increases, which is most likely true when the amount of training data increases. So training data, so the options are training data usually decreases and generalization error usually increases. Training error usually decreases. Just a minute, somebody is joining. Okay. Yeah, so training error usually decreases while generalization. So basically, you have 4 possible combinations of training data and training error and generalization error. So the first point is, if your training data increases. Now this question is likely, I mean, it's I mean, there has been nothing has been told to you about your model or anything. So in that case, what you would have to assume, I guess, is your training data, I mean your training model is very powerful. Okay, so that is the assumption that you will have to make given the question that has been posted here. So if your training model is very powerful, then your training, it will learn everything that you have given it to train, right? Then that you have to given that you have given it to train on, and your training error will go on decreasing in that case. Okay, who wants to join the call? Okay. Right, so your training data will go on decreasing, and this is also one possible way in which you can think of. I mean, suppose your model is not doing, suppose your model is not doing, okay, let's say you have a case where so you are training a model which is a very simple, let's say, dog cat classifier. It's a very simple model. You are training that model, you are training it to classify dogs and cats. Okay, now you have, let's say, 1000 training examples, and out of those 1000 training examples you have 800 dogs and 200 cats, or let's say you have 900 dogs and 100 cats. Okay, this is your distribution. In this case, what you will see is your model itself, your training won't be as good. Actually, you shouldn't say your training won't be as good. Okay, let me give you No, let's not give this example. This example will confuse you further. So okay, let's not give this example. This example will be confusing. So let's say you have training data points. You have training data points of, let's say you have 10 classes and you have one image per class. Okay, in such a case your model probably won't be able to classify your images into the proper class, because it has to look at 10 different images and classify them into 10 different classes. It most likely won't be able to do that. Okay, so in that cases your training model itself, your training error itself will not decrease. So the only way you can solve this problem is you will have to increase the number of examples per class, and therefore your training error will start decreasing. So that is one aspect. However, the other thing which I have told multiple times is, if your training error goes on decreasing and if your model has no limit to its power, then it will start overfitting on your training data, and in that case you won't be able to generalize well, or which in other words means that your generalization error will be quite high. So if your so that is the case, that training data increases, your training error will decrease, but generalization error will increase. Okay, is this clear now?
Sir,
Yeah.
this seems to be little contradictory to like at least what we have seen, right, sir? The understanding is like whenever, and it might be this one specific scenario, sir, you have taken. In general, if we see,
Yeah.
if there is a model
Hmm.
and if there is some classes, so it has like n number of samples.
Hmm.
If it has trained, so which means if it has trained to that, it is kind of, let's imagine if it is complex or not, but it has trained to those n number of samples.
Correct.
Very
Yes.
nicely.
Yes.
And now if that n keeps on increasing,
Yeah.
and after a certain stage, the model can't just go ahead and fix all the training samples. So that is why they say that if n is more, like if it extends the population, which is practically not possible,
Hmm.
then in that case training error will usually increase and generation error will decrease.
See, here what you are assuming here is, again, I mean, the thing that you said, that there can be, after a particular point your training error will go on decreasing. Training error will start to increase. That point always takes the, I mean, this particular question has been set with the assumption that the model is very powerful. Okay, so in any machine learning setup you will see that normal, whatever, the 3-layer neural network also, the whatever, I mean, if your training error is, let's say, 0 at one particular point of time, and if you add more amount of training data to that particular model and train it again, it will again reach the same 0 error, but after some time, let's say. So earlier if you had 1000 training examples, it might reach the training error of 0 after, let's say, running it for 2 hours. Now if you include 1 lakh more examples, it will probably reach the training error of 0 after 2 days, but it will still reach the training error of 0. It will be able to train, you will be able to fit the training data perfectly if your neural network is strong, or if your machine learning model is strong enough. Is that clear now? I mean, the assumption that you made, that after some time the training error will go on increasing, that is true. That comes only when your model is of a particular size. Okay, your model should be of a particular size, or you should regularize your model. That is the reason why you need to add regularization explicitly to increase the training error after one particular point of time. It is, I mean, this particular reason as to why the training okay, for example, why did you need to add regularization? You needed to add regularization because your model learned your training data so well that it did not generalize well, correct?
Right.
Now then why did you need to add generalization if you knew that if I only add more training data, then my model will then my training error will then my model will start generalizing.
Can you repeat that last sentence, sir?
Yeah, so what you said before depend, I mean you so you agreed that we add regularization to our model to help it generalize. You agreed to that part.
Right, sir.
So now I can go back and ask you the question, why did you need to generalize your model? I mean why did you need to
Regularize.
regularize your model? If you could just add some more training data, then your model would not overfit, right? I
But
mean,
but
yeah,
practically that training data should be available, right, sir? If more and more samples to that
huh,
extent should be available. So in at least might be I have seen some graphs. I don't know if you can give me some time, I can just pull it out, sir. Might be if we can go to next question, where
okay,
even for overfitting also,
hmm,
the training error will increase but not increase to that extent. It will still little increase.
hmm,
If the model is complex also, it will
hmm.
increase, but generalization error will decrease because the more
S-
and more training data we add, the model fitting to that data, because if it is less data it will fit very well. If we add more and more data it will fit little less. So
I mean that actually from, I mean I am telling this to you from a practical point of view. What I am trying to say here is let's say you have training data. I mean suppose for example this curve which I am drawing, this is a bias variance curve if you remember, okay. This is the bias variance curve. So this is the okay, this is the bias curve, and this is the variance curve, and this is the model complexity, right?
yes, sir.
Now here whatever I think that whatever you are saying is based on this particular curve, am I correct?
No, sir, not for with complexity. With
Okay,
respect to training data only, might be if you can
okay,
give me few minutes, sir, I'll try to see if I can pull that out.
okay.
Uh,
So then what I mean from what I have seen in my work also is basically what happens is if you add more and more training data, then if I mean the curves that you might have seen which you are referring to, it might be, I mean you are constraining your training in some sense. For example, either you are constraining your model, either you are constraining your model complexity, or you are constraining your model time, I mean the training time, because it's always remember that it's a rule in machine learning that if your model is as complex as possible and you're training it for sufficient amount of time, your training error will go down to 0 at some point of time.
okay.
The curves that you are seeing, just I mean that you are referring to, just see it once more, saying whether it constrains the model complexity or it constrains the model training time. If that is the case, then what you are saying is true. But if your model is allowed to run forever with as complex a model, it will most likely fit the training data perfectly at some point of time.
Okay.
Okay.
So, okay, let me see, sir. I was able to pull something. Let me see if I can share it.
Okay. I mean, I don't
Uh,
know whether you can share it in the chat box.
okay.
Uh, uh,
Hmm.
Somebody's question 5 week 1. Okay. Question 5 week 1. Okay. You trained a learning algorithm and plot the learning curve. The following figure is obtained. The algorithm is suffering from high bias. Okay, training error has increased and test error has decreased. Are you talking about this particular curve which was there in the question 5? Uh, Here, as the training set size is increasing, the training error is also increasing. Hello? Yeah, so the correct answer for this would be is correct, which is high bias, because your training error is also very high, which means that your model is not learning that much from the training error, from the training set. Okay.
But what I see in the web is
Yeah.
it is high variance. Bias will come when you go the training set far away from what you are showing. So I have a diagram to share with you, but I cannot share the diagram. How to share a diagram?
I don't know here. Okay.
Because I have that diagram with
See
me.
here, I mean, for example, for this particular case, what is happening is, okay, I will draw this diagram here. Okay, and let me see if I can draw this diagram here. So this is point 4, okay, and this is test error, and just a minute, somebody is trying to join. Okay, yeah, this is test error, and this is training error, and this is the training set size. So what is happening here is, this is a perfect, actually this answers the doubts of the first question, I believe. So you see what is happening here is, first of all, this diagram, this particular diagram is different from this particular diagram, in the sense that on the x-axis there is training set size. Here it was model complexity, here it is training set size. So here what you are seeing is, as your training set size is increasing, your training error is increasing. Okay, which means that whatever data you are giving to the model is not learning from that. On the other hand, it is getting some errors because of that. So that means that your model is not learning from the data that you are supplying. Whenever it is doing something of that sort, it has to be high bias, it cannot be high variance, because if it is high variance, that means the training error would have reduced. Okay, and yeah, and the other thing which is the case is like test error. I mean, one thing which you can one thing which you can say here is that your test error is decreasing. So that means, I mean, that might lead you to think that this is high variance, but as has been given in the solution, the test error is still above this particular whatever, I don't know what is this. This is some, I mean, your test error has not gone down below the training error. Okay, so that gives you an indication that it is not high high variance, because then your training error, your test error would have gone down below your training error. In that case, you can say that it is high variance, but since here your training error is still lower, but it is increasing with your training set increase size, which that means that it is a high bias case. I hope this was clear.
Sir, I shared a link, sir. Might be if
Okay.
you can click the link in the chat. I want to see.
You have given two
Yeah,
links.
in any one, sir. I think
Okay,
it is
okay,
displayed.
okay. The bias variance trade-off. Okay. Which diagram should I look at?
Sharing that screen, sir. I am at least not able to see it. On
Oh, I am sharing my screen from my iPad, so that's why you can't see.
Oh.
I am seeing it on my laptop. So which diagram?
Okay. If you can go further down, sir, under learning curves, the basic idea.
Okay, yeah.
Under that, there is the example of how the training set and validation set graphs are there with respect to increase in training samples.
Okay.
So here, if it is less, then how it will kind of very much overfit to that, and if it increases to more extent, then after certain point, it cannot completely fit all those models. So that is why it kind
Okay.
of says that if training set size increases, then training error will decrease, but validation error, training error will increase, but validation error will decrease.
Okay, this is uh, okay, I have to look into this, but this, if they are not constraining the models, or if they are not constraining the if they are not constraining the models, or if they are not constraining the model training time, then this is not correct. That much I can say. Okay, they must be doing something. Their model is either fixed or they are doing something else. Okay, so I'll look into this. And I'll let you know by next class. Probably they are doing something that that they are not saying here, maybe, but
Yeah, at least whichever diagrams we look, sir, in the
huh,
internet, at least all show the same type of graph. So that is why we are a little confused. At least
huh,
I'm a little
huh,
confused.
huh, huh. So
And
there, what I mean, there in most cases, what they would do is they will always say, I mean, see the I mean the setting that they are coming from, in the background from where they are coming. Okay, this particular model, this particular web page which you sent in the chat box, what they are coming, where they are coming from is, suppose you have a model. Okay, that's the first assumption that you will take. Suppose you have a model, now your model gets fixed. Okay, now depending on the number of, now let's say you give it here, as they have said, you give it one sample to train on, then you give it 10 samples to train on, then you give it 80 samples to train on, but at the back end their model is always fixed. I am saying my answer is something different. My answer is, suppose your training data is increasing, and there is, and suppose you have a 10 layer neural network on it. So it doesn't matter to the model whether you give it 80 samples or 8000 samples, it will go and fit the training data perfectly at some point of time.
okay, at least we thought with respect to this linear regression model, like where like a line, like however it
If you have, for example, a linear regression model, then at one particular point of time, of course it will start to get more error on the training set, because of your hypothesis being so strong that it is a linear regression model. Now suppose your hypothesis is also free, I mean you can choose any model in the world that is out there, then 80 samples, 1000 samples, 1 lakh samples doesn't matter to you, it will go and fit, it will go on and fit your model at, if you give it 10,000 samples, it will fit it perfectly. If you give it 1 million samples, it will fit, but after maybe some more time, it will train for some more time, but it will fit.
Okay. So in that case, the
Yeah.
error for 10,000 samples will be still more than the error for 1 million samples, is what you say. Training error.
uh, Training error for, I mean again, training error is a very dicey term to use. So training error depends on depends on two things: how strong your model is,
Yeah,
and
let's consider the strong only, sir, like whatever you were mentioning, right? The
uh,
neural model, whichever is
correct.
focused on.
So and also the time for which you are training. Okay, so if you are training both the models, one model which is being trained on 10,000 samples, another model which is to be trained on 1 million samples, if you train them for the same amount of time, okay, then the model which is trained on 1 million samples will have more training error than the other one, because it has to be given more time to fit all the data points.
Okay.
Now let's say you train all your models for eternity, I mean you train them till you get your training error to be 0, then at some point of time you will indeed get both the models to get to training error of 0. That is the only statement that I am making.
Okay.
Okay.
Yes.
Okay, sir.
Soumya sir,
Yeah.
this is Balaji again.
Yeah.
On question 5, week 1. I
Right.
have given one link from Cornell University.
Yeah.
And in that, if you go to the second or third page, he gives the diagram of how the training set increases, where exactly the variance is, where exactly the bias is. So in that diagram, very clearly he shows
Huh.
that this diagram, whatever you have given, is a
Hmm.
high variance case, not high bias case. And he shows where exactly is the high bias, which is on the right side. So kindly have a look at this and then throw some light in the next class. No issue on that.
Yeah, so the right side, so the right side is the high bias, right?
Very high if you go, not like this one. If you go far away, then only it is high bias. It is
Huh.
not, this diagram, whatever you are showing is just, high variance. That's what,
No, no, no,
that,
no, no, no. You are
that
again,
picture,
I
have
mean,
you,
yeah,
have you
so,
looked at that picture?
yeah, so that diagram is something like this, right? This is the acceptable test error, which is epsilon, right? And this is the test error, and this is the training error.
Ah,
So they are saying that this is the high bias and this is the high variance.
correct.
So this is the exact same analogy of this, right? I mean, here also it is high bias, and this is the high variance region.
High variance.
This is the
If
high
you,
variance
if you
region.
see, if you see that
Huh,
the training error and then test error
yeah,
far away,
huh,
then only it is called high bias.
correct, yes,
Whatever you have shown as still
huh.
that area is still under high variance.
This area is still high bias, right?
That is just a starting point. But if you see on the left side, whatever you see, that it is a high variance area. If you have a look at that diagram one more time.
Oh, what you are saying effectively is this is the high variance region, this is the high bias region.
Very correct.
Huh. So,
That is the one which is confusing all of us. If you carefully look at this link, he gives training set when it is far away. Then this test error and training error will be parallel. At that time, we call it as high bias. Whereas this region, whatever you have given as a diagram, is a high
right.
variance region. Have a look at that.
I am if a
You have a
classifier.
look at that, then you will see.
Yeah, I have seen that. So the only confusion here is, I mean, the particular diagram which has been given in the assignment, it has both the high bias region and the high variance region.
Mostly it is high variance region. He has given high bias region, only he has just touched. The high bias region is far away onto the right side, then it becomes a parallel line.
I
That is
think,
called high bias region.
yeah, so I think what he is trying to say here is what I mean, I think now that this question probably they should have marked which region they are actually referring to. See, if one example is, I mean, this particular diagram is one diagram, this diagram is another diagram, okay? It's not like that if you only they have to become parallel, only then they will become high bias. It is, I mean, the idea is if your training error increases with the training set size, that means your model is not learning from whatever data you have given it to the model, and therefore that is a high bias region, okay? And so here if you will see what they have given the question is, I mean, I am now talking about the assignment, okay? You trained a learning algorithm, okay? So that's the first question. You trained a learning algorithm and plot the learning curve. The following figure is obtained. So what they are trying to say here is that this is a learning curve that you have learned, and now you have trained and now you are starting to increase the training set size. I mean, that's how you can see that if your training set size increases, then your training error also starts to increase. That is something that you are seeing because you have trained a learning algorithm and you are starting to increase the training set size. Now you are seeing that your training error is increasing, which means that you are suffering from high bias. But I have some problems with this question. I agree with all of you that yeah, they should have marked the region. I mean, for example, when I did not know that other curve from Cornell existed. So for me, when I saw this curve, the first thing was, okay, my training set size is going on increasing. I have a machine learning model and my training error is also increasing. That means that it's a high bias situation. Okay, so this question could have been posed in a better way, but yeah, that's how it has been posed. So yeah.
Thank you.
Yeah. Okay, so the other question was about question 7. Now question 7, the answer is wrong. They have given some precision, recall and accuracy accuracy definitions. If I am not mistaken, the accuracy definition is incorrect. It should be true positive plus true negatives. Was that the doubt?
Yes, sir. I think option B should be there, right, sir? 1 and 3
1 and
are
3. 1 and 3 should be correct. Yes,
okay,
yes.
sir.
Yeah. So that is one. That completes assignment 1. Now going on to assignment 2. Assignment 2, which question was it? Assignment 2, 11. Okay. 11. Okay. Which of the following techniques can be used to handle overfitting in decision trees? Okay, one is pruning. Pruning is for sure, and the other they have said decreasing the minimum number of samples required to split a node. Okay. Okay. Decreasing the minimum number of samples required to split a node. That will not.
Yeah, it actually
Uh-huh.
increases, sir. So that is what even we felt. Because whenever we decrease the minimum number of samples, then it means again we are overfitting. So we are trying to increase the tree depth. So in that case,
Mm,
so we had a example like example if we define that the number of samples should be 50, sir. So
okay.
now if it reaches 50, then we decide to split a node. Now from 50 to if we decrease the minimum number of sample to 10,
Hmm.
so then every time the sample size is 10, you keep splitting the node. So you don't average it out well. So that is when
Decreasing
the
the minimum number of samples required to split a node. Okay. What are they trying to mean by this? Okay, let's say I have decreasing the minimum number of samples required to split a node. Okay, so if it is, let's say as the example that you gave, so let's say it is 50 in the beginning, that means that if only if the number of samples crosses 50, I will split the node,
right.
and if the number of samples is now decreased to 10, then whenever I have 10 samples, it will start splitting the node. I think this is incorrect. I still have to go through properly because I don't know whether. So have you asked the other TAs about whether this is correct or not? What have they said?
Yes, sir. Like one session I've asked about in this the other TA, sir. Like there even that sir also felt this was correct, sir. Like C should not be the
I also think
right
so,
answer.
but I don't know why they have given this. I also think that C shouldn't be correct. Yeah, if you decrease the number of increase might be okay, but
Right,
decreasing the
right.
number of samples, it should lead to more overfitting. That's what I feel. Yeah, I think A should be the only correct answer in this.
Okay, sir. So, but when will they get back, sir, on this one? Because
Oh, that I don't know, because you see what we are not in charge of all these assignments. Okay,
okay.
so there are a separate set of TAs for these assignments, and we are separate. Okay, so I
Because
don't.
a lot of us are posting in
Huh?
our discussion forum, but still we are like
No.
waiting for that answers.
Okay, okay. Okay, I really don't know. I mean, we don't even know them. I mean, we three TAs, one session is on I think Saturday or Sunday. The other one is on other one is yesterday, and the last one is mine. We three TAs are I mean, we communicate with one another, but the actual TAs of this course, we don't have any communication with them.
Okay, sir.
Okay, so I'll close these and come to the actual
Sorry, and
topics for.
assignment 3, sir.
Yeah,
Last assignment
yeah.
had only one simple question, sir. Like
Huh.
there was again not you. Are you able to open, sir, assignment 3?
Let me, I had closed it, let me open it again. Just give me a minute. Okay, assignment 3. Just give me a minute. It's actually
Question 9, sir.
it's very slow. Question 9. Yeah. Oh, I, I don't know this. In collaborative filtering based recommendation, the items are recommended based on similar users. Collaborative filtering based recommendation, items are recommended based on, it should be both of the above, right?
Right, sir. That is what even
I
we
mean,
felt,
no,
both of the above.
I don't know much about this, but I also feel that it would be both of the above.
Okay, because even in the ma'am's lectures, also we it was mentioned that it was both similar
It would
users
be, I
and
mean, ideally for recommendation, it would be similar users as well as similar items, of course.
right.
I mean, yeah, it's common
Okay,
sense in some sense.
someone has mentioned, sir, in the chat that in case if we don't get answers, we can write to the professor in charge.
Oh, that
So
I don't know.
thanks.
That I don't know.
Okay,
That I
no
don't know.
problem.
Yeah.
Okay, sir.
Okay.
No problem. Thank you, sir.
Thank you. Yeah. So, on. Okay, not this one. This one. Okay. Okay. So now coming to this particular topic for today. So it was some Bayesian networks. So I thought that mainly I will go through some problems for this, and maybe that would be enough. So the first question is, the figure below shows a Bayesian network with 9 variables, all of which are binary, and which of the following are always true for the above Bayesian network. So let's consider each of them one by one. So the first one is P of A comma B, which is A and B. They are independent, conditionally independent if you know G. Okay, so do you think that this is correct? See, the first thing is A and B would have been independent. Now whenever you know C, okay, for example, whenever you know C, then A and B ceases to be conditionally independent. They are conditionally dependent on each other in that case, because now you know their child, so therefore the two parents will now be conditionally dependent on each other, and G appears somewhere in this line G appears. So of course once you know G, then you can't possibly have A and B to be conditionally independent of each other, because G appears much below there. I mean, G in some sense is a descendant of both A and B. Therefore if you know something about G, they cannot remain conditionally independent of each other. So that is one. Okay, then the next question is P of A comma I is equal to P of A into P of I, which means that this one, okay, I will rub the others, this one, which says that this and this are independent of each other. So you see I is affected by H, and H is affected by F is affected by E is affected by B, and B is now independent of A, because you don't know a common child of both of them, and therefore A and I would be independent of each other, due to which this condition will hold true. Okay, the other two, I think, they are simple enough. B and H, they are conditionally independent if you know E and G. Okay, so let's say you have E and you have G, and now you are saying that B and H are independent of each other. Okay, so somebody is saying something. sir, please disable waiting room when meeting starts. Yesterday I was in waiting room for nearly 1 hour. Oh, I also want to disable that. I need to figure out how to disable that, because I otherwise, okay, let me try to disable now only. I don't know how to do this. Settings, just give me a minute, let me see if I can disable. No, it seems like I am unable to find how to disable that. Yeah, I have disabled for this meeting at least. Okay. Yeah, so and the other question was about the tutorials. The tutorial links I am sending to NPTEL people. I hope they are giving those links to you. I am posting them on YouTube, so you will be getting them on YouTube. Okay, so then we so this particular thing, that E and G is known. Now you know E and G, and this B and H has to become independent of each other. Of course not, because you see what is happening is B is here, okay. Okay, let's say E is here and G is here. Now the value of G will depend on D. Also, it will also depend on C, then C will also depend on A, and therefore what is happening is so what is happening here is B and H will again start depending on B. So you can see that B and H, they cannot be independent of each other, because whatever values B will take will start affecting F, and once F gets affected, H also will get affected in that way. Therefore B and H cannot be independent of each other, and so this also is not true. The final thing is, I'll rub all of them. B of C comma B F, C given B and F is equal to, okay, what is, where is C? C is here and F is here. So suppose you know B and F. No, this can't be, because C depends on both A and B. Therefore it doesn't matter whether you know B and F. I mean, it will still depend, it can't be independent of B, right? Because I mean, it can't be independent of B because it still depends on A. Therefore B and F only, it can't only depend on F. Okay, so yeah, so this can't be true, right? So now we have some problems. Okay, two problems I believe. One of them is slightly longer. So two problems. So the first problem is, let's say we have consider the following data for 20 budget phones, 30 mid-range phones and 20 high-end phones. Consider a phone with 2 SIM card slots and NFC. I don't know what NFC is, but no 5G compatibility. Calculate the probabilities of this phone being a budget phone, a mid-range phone and a high-end phone using the knife Bayes method. The correct ordering of the phone type from the highest. Okay, there are many things. So there are 3 features. Okay, single SIM, 5G compatibility and NFC, and the class is either budget, mid-range or high-end. So let's say the first thing is, so the output that you need to get is the probability of the phone being budget, given that it has 2 SIM card slots, 2 SIM, it has NFC and it has no 5G. Okay, so going by the knife Bayes assumption all of these 3 features are independent of each other, and going by the Bayes rule also, it would be like 2 SIM given budget into NFC given budget into no 5G given budget into P of probability of budget. So that is the naive Bayes formulation. So probability of 2 SIMs given budget. So if you see here, there are 20 budget phones, out of which 15 are single SIM. So that means this would be 5 by 20. NFC given budget is 0 out of 20, so that is 0 out of 20. And 5G compatibility, there are 5G compatible phones in the budget category, so this would be 15 by 20 because this phone doesn't have a budget, and into the probability of budget. So out of 20 plus 30 plus 20, which is 70 phones, we have 20 budget phones. So this is 20 by 70, which is equal to 0 because this is 0. Okay, so likewise you can find the so the next thing that you can do is you can find it for the mid range also. So mid range given 2 SIM cards, NFC.
Sir,
Yeah.
here, right, sir?
Yeah.
As per Bayes formula,
Yeah.
shouldn't we divide that by probability of 2 SIM, comma NFC, comma no 5G? Because the P of A given B is equal to P of B given A into P of A divided by P of B, right, sir?
Okay, so yeah, let me come to that. Let me
Okay.
first do this and I'll come to that. Yeah, so no 5G. Okay, so here the formulation would be 2 SIM given mid range into 2 NFC given mid range and no 5G given mid range, okay, into P of mid range. Okay. Now this would be 2 SIM given mid range. 2 SIM given mid range is okay, 2 SIM given mid range. So out of 30 mid range phones, 20 have single SIM, so that means this would be 10 by 30. Out of 30 mid range phones, 15 have NFC, so this would be 15 by 30. Out of 30 mid range phones, 5G, 20 have 5G, so that means this is 10 by 30. And the final thing would be the mid range, which is 30 by 70. So this will be something, okay, 30 will get cut, this 15 and 2, this 10 by 3, this 10 by 7. So this would be 1 by 42. No, 1 by 42. So this would be 1 by 42, the other would be something like that. So the answer for this would actually be so budget would be of course the end, and this would be mid range, high end and budget. I did not calculate the high end part, but you can do it in a similar, or I will do it myself maybe. High range given 2 SIM NFC and no 5G, which would be 2 SIM given high range into NFC given high range. I'll write HR for high range, and no 5G given high range to P of HR. So 2 SIM would be out of how many phones? 20 phones. Okay, so 2 SIM would be 5 by 20, NFC would be 15 by 20, no 5G would be 5 by 20, this would be 20 by 70. So 20 20, okay, this would be 4, this would be 4, and this can be 3, this can be 14. So this would be 3 by 56 into 4, 16 into 14, which is 1, how much, 160, 192. So I think, yeah, 3 by 192 will probably be lower than 1 by 42, and therefore this would be mid-range, high-end and budget. Okay, now coming to the question that you asked, that why are we not dividing it by by the denominator that is generally there in Bayes rule. You see what is happening here is you are always taking the argmax of the hypothesis. So in this case the hypothesis is whether your phone is high range or whatever, okay, high range, low range, budget or mid range. If you are taking the argmax of this, so what is happening is you have the data, you have the age, and you have the probability of data. Okay, how did this come by? This came by because you are trying to take a argmax of p of age given d. That given that data, given that you have seen this data, what is the probability of your, what is the most likely hypothesis? Is this clear?
Yes, sir.
Now,
So,
yeah, so now when you take the argmax of this, you don't consider PD because PD doesn't contain any age in this case. So it's as good as taking the argmax of the numerator and ignoring the denominator completely, and taking the argmax of this itself is leading to all those calculations that I showed above.
okay, since here we are comparing, then
Yeah.
taking only numerator is enough. But in
No,
case
even in all cases your numerator should be enough, because see, so you have to, there is a difference between max and argmax. Okay, so for example, max of say, let's say your x, you have a variable x which lies between -1 and 1, okay, and you say that max, or let's say -2 and 2, and you say max of x square. Okay, so what is the answer of this? Just consider a problem where your x can lie between -2 and 2, you are trying to maximize x square. So what should be the answer of this?
4.
What is the argmax of this?
4 only.
No, argmax is 2 or -2. So let's say in this case I am constraining -1, x lies between -1 and 2, max of x square is equal to 4. Okay, argmax is the value of x at which this function assumes the maximum value, which in this case is 2.
Okay.
So that is why when you are taking the argmax of p of d comma a, so argmax is over what? Argmax is over h. So whatever h will maximize the numerator, that itself will be the argmax, right? Because h won't be able to affect PD at all. Am I clear?
Right, sir.
So that is why you just take the numerator.
Okay, in case if they ask what is the probability of high range, like whatever you had, sir, high range given 2 SIM, NFC, no 5G.
Huh.
So this formula is suffice. So it is,
Huh,
and you do not divide is what you're saying, right, sir?
Uh,
Because sometimes we have questions like what is the probability?
Then you will have to divide by PD.
Okay, okay.
Because
That
this
what-
is not the probability. This is not the probability. This is because all of them is divided by PD. While comparing, it is fine.
Okay.
But of course, if you are doing max, in that case you are doing the max operation, then you will have to give the actual value. Then you can't, but nobody will ask you for this type of question, nobody will ask you what is the maximum value of the probability. Okay.
Okay, sir. Got it.
Yeah. Okay, so I don't know why this came, but okay. Right, so the next question is I should have started writing much later. Okay, I don't know how to. Okay, I thought that this question might be useful to all of you because this was referred to also in the class, I believe, but it was not it was not described in a proper way. So that is why I thought of giving this. So I will talk about, so here it's the same thing almost, right? It's almost the same thing. So you have been given a data set of when you can play tennis and find the probability that the student will not play, given that you have been given some data points. So this is exactly the same problem as before. Using the knife Bayes method, assume that the continuous features are represented as Gaussian distribution. So this is where I wanted to throw some light on. So again, this would be the same thing, right? So so what you are required to find out is probability of no given x. Okay, yeah, actually here you are required to find the probability. Okay, so so the one thing that you would need to do here is but I think still this still gives this still doesn't divide by the new denominator. That's what I feel. Anyway, okay, so probability of no given x is given by x given no into p of no. So p of no you already p of no is already known. This is known. I mean, you can find out directly from here. It would be what? 1 2 3 4 5 by 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So this is 5 by 14. This is already known to you. This you need to figure out by means of the knife Bayes method. So what are the features that have been given to you? Outlook is sunny, so that means x given no equal to p of sunny given no into p of temperature equal to 66 given no. Humidity of 90 given no, and windy equal to true given no. This is easy. So you check out all the cases where it is no. So there are 5 such cases, and out of which sunny is there in this is rainy, this is also sunny, this is rainy. So sunny is there in 3 cases. So this is 3 by 5. Wind equal to true, not wind equal to true and no, also that also you can find out. This is one case, this is another case, and this is one case. So this is also 3 by 5. This is also 3 by 5. Just let me check, both of them are 3 by 5, is it? Okay, let me just check the solutions once, and I will yeah, so both of them are 3 by 5, and this is 5 by 14. Now I'll show how to handle a continuous variable. I'll just show for temperature. Humidity, I mean, I will not show the full calculation, I'll just tell you how to work them out, and the humidity can work out in the same way. Okay, so so the main point, the key note here is the continuous features are represented as Gaussian distributions. So which means that all these, the temperature values, they are all Gaussian distributions. Okay, so so now what you need to do is you need to figure out, you need to find out the values which correspond to no and the temperature values which correspond to no. So these are the 5 temperature values. So I am writing them next page, writing them some in the I should have written it here, but I have already filled those up, so I'll write 2 pages later. 85, 80, 65, 72, 71. 85, 80, 65, 72, 71. I hope I'm correct. 85, 80, 65, 72, 71. Yeah. So these are the 5 values. So they are all Gaussian distributed. That has been told to you. So the simple thing to do would be to add them all up. So you need to do 2 things. Seventy-one by 5. You need to get the mean. So this will become the mean. Okay, and so once you do that, then the next thing that you will need to do is you need to calculate the standard deviation of the variance. So you need to divide this by 5, you will get sigma square. Okay, so now you have got the mean. Suppose you get the, I mean these are normal simple calculations, you do it and you will get mu and sigma square, and once you get mu and sigma square, then you know that your the temperature is Gaussian distributed, and therefore you just need to put the Gaussian distribution term, the Gaussian distribution expression here, 1 by root 2 pi sigma square minus half x minus mu whole square by sigma square. Okay, this is what you will need to do, and then here it has been said that your temperature is 66. So you just put 66 here, you put 66 in place of x, and you calculate this, and this will give me, and this will give you your, because you know mu here, you know mu here, you know sigma here, and this will give you the probability of of temperature 66 given no. Similarly, you can also find out the probability of humidity 90 given no, and you multiply all of them, and that should give you an indication of the probability about what the student will whether the student will play or not play. So if I am not mistaken, in naive Bayes method, I mean the question that was asked before, in naive Bayes, if you are saying that find the probability that the student will not play using the naive Bayes method, in most cases you won't have to do the denominator part, you can just leave it and just compute the numerator part, and that will be your answer. Okay, so yeah, so that is it. Was this clear about how you can handle the continuous variables? Okay, so let me solve one more question. I don't have it printed, so I will have to write it down.
One question, sir.
Yeah.
Like about the denominator only. So in the notes, in the lecture notes, sir, there was an example regarding about the patient having cancer or not. So there, that formula they have divided, sir, divided by.
So that is the probability of that is, see, your naive Bayes is a classifier. Okay, so naive Bayes means that naive Bayes is the so that was in the first part of the course, if I am in the first lecture itself. So in
the first lecture.
So here what you are, see, naive Bayes is a classifier. So the assumption behind that classifier is this sunny, this temperature, this humidity, and this windy, all these, they are independent of each other. Okay, that is why it is called naive Bayes, because it's a very simple assumption, but sometimes it, I mean sometimes it works quite well. Okay, so whenever you are talking about naive Bayes classification, or naive Bayes method or whatever, in most cases the thing that you will have to do is you will just have to take the argmax of this, because your final thing is whether the person will play or not play. In this case it was what phone it was, in this case it would be whether the person will play or not play. However, if you were said that I mean, of course this question has been written in that way, I mean find the probability that the student will not play. Ideally you are correct, I mean in this case you should also take the denominator. I feel that you should take the denominator, but in the solution somehow they have not divided by the denominator. So one thing which I would suggest is, whenever you are given this sort of question, you should always divide by, whenever you are seeing that find the probability, then you should always divide by the denominator and give the actual probability. If you are asked that say what the naive Bayes classifier will predict, in that case of course you don't need to divide by the probability.
Right. If they ask about map or
Huh.
maximum
Correct.
probability, then no need to divide.
No need to
the
divide.
denominator.
Huh,
If
huh.
they ask the exact
Probability
number of
you should
probability-
ideally divide.
Okay, got it.
Huh.
Thank you.
Yeah.
Sir, can you I joined little late. Can you tell me that the denominator
Huh.
in the case of that example given in the cancer patient, whatever the lectures given in the first slide,
I don't
the P of
have,
D is there. Do you know the P of D? Can you give more clarification on?
no, that is the base formula, right?
Yeah. In that P of D,
Huh.
in related to the probability of the cancer patient, one example is given in the class.
Okay, I am not.
Can you give the P of D? What is the meaning of? Because in that example, sir,
Huh.
we know the probability of other things, but except P of D is not very clear. So I think when I'm joining, you are explaining that part.
Okay, I was not explaining that example actually. I need to pull up that example. I don't have it with me right now.
Okay.
So
Or any other example in general, what is the P of D also? Okay.
okay, let me try to
Out.
figure
Yeah,
something
yeah,
out.
yeah.
Just give me a minute.
Thanks. Yeah.
Okay, so okay, so let me devise a problem here. Okay, I think I have this thing also. Okay, let's say I have I'm sorry, I don't have the cancer the example with me, so I'm trying to give a different example. So let's say I have a spam filtering system. Okay, these are common examples, all coming from the same set of problems maybe. Anyway, so this filtering system has a probability of 0.95 to correctly classify and email as spam or not spam. Okay, and 0.1 probability of giving false positives. FP is for false positive. Okay, now it is estimated that 1% of the mails are actual spams. Okay, so now the question is, suppose that the system is given a new mail. What is the probability of the mail being classified as spam. Is this okay now? Is this example fine, or was it different? I think it was different, no?
Okay. This example is okay, fine, but it is almost similar to the question which is asked in current assignment, week assignment. That's what.
Oh, is it? Oh, then I can't
that's
solve
what
this. Oh, then I can't solve
Yeah,
it.
yeah. should
Then
not-
then
yeah,
I
yeah, that's why I'm informing you.
okay, okay.
Okay.
Then I'll skip it. Yeah.
Yeah.
Okay, okay.
That's
Then
why
I'll
like in cancer one you can take, no, then it will be no confusion.
is there any, okay, then I must have taken it from there only. Okay, so
Yeah.
last time actually this was 2 years back, it was again in assignments probably. So that is why I have
No,
it.
it's not exactly same number, but almost same it is.
Sir, I'm sharing the description of our notes, the cancer description
Okay,
examples
okay,
in
yeah,
our chat.
yeah. Does patient have cancer or not? A patient takes a lab test and the result comes back positive. The test returns a correct positive result in only 98% of the cases in which the disease is actually present, and a correct negative in only 97% of the cases in which the disease is not present. Further, 0.008 of the entire population have this cancer. Okay, so
And
okay,
then they
okay.
have provided the formulas for patient having cancer given he was tested positive, and patient not having cancer given he's tested positive. So these both formulas are being given. I don't know how to, because those plus and minus are not getting pasted.
Okay,
well.
okay, okay. So let me so just tell me beforehand, before I write this example. So do you have something, any question like bag 1 contains certain number of balls, bag 2 contains certain number of balls, and so on? So in your assignment
No, sir.
you don't have that, right?
No.
Okay, then I can safely give this example. Okay, okay, I'll give one example. This will clear the doubts. I mean cancer and okay, I'll give a simpler a more happier example, let's say. Okay, so you have bag 1 and you have 4 white and 6 black balls in this. Okay, you have bag 2, you have 4 white and 3 black balls in this. Okay, and a ball is drawn at random from the bags. One ball, hello,
ఏం కొన్నాంపా 800 800 అయింది.
one ball is drawn at random from one of the bags and it is found to be black. What is the probability that it was drawn from bag 1? Okay, so this is more or less a similar sort of a situation. So here what you need to do here is, so of course you need to apply the Bayes rule here. So first let's see what is I mean all the things that you have been given and what you have been asked to find. So what you have been asked to find is query. So query, so this is what you have been asked to find. Okay, given that you have a black ball, what is the probability that you had selected bag 1? Okay, given that you have been, so the question is one ball is drawn at random from one of the bags and it is found to be black. So this is true, this has turned true. So what is the probability that it was drawn from bag 1? What is the probability that it was drawn from bag 1? Okay, this is how this is what you are requiring. And so if you have the Bayes rule here, So what will it do? It will say, okay, this is what I have to find. So if you write here B of black given bag 1 into P of bag 1 divided by P of is this correct?
Yes, sir.
Right. So now you just, so this you already you can calculate, because P of black given bag 1 is P of black given bag 1 is 6 by 10, right. You have 6 black balls, you have total 10 balls, and P of black given bag 2, you just need to find that out also. So that would be 3 by 7. Okay, so okay, so what is P of black? What is the probability of you picking a black ball? So the first thing that you need to remember is you can choose bag 1. Now that you have chosen bag 1, what is the probability of picking up a black ball? Or another way you can pick a black ball is you have chosen bag 2 and now you have picked a black ball from bag 2. So you can choose either of the two bags with equal probability of half into black of black given bag 1 is 6 by 10 plus again half for selecting bag 2 and 3 by 7. So that is the denominator. So this is the data that you were talking about, that you were asking about, and black given bag 1 is 6 by 10, P of bag 1 is 6 is half. So the answer for this would be 6 by 10 into half divided by this big thing, 6 by 10 into half plus half into 3 by 7. So something will come here. So this would be 6 by 20 divided by 6 by 20 plus 3 by 14. Something will come. Okay. Yeah. Okay, I hope this was clear how the denominator got. So the denominator was precisely because of this. So yeah, so I hope that was clear.
Sir, I have one question, sir, regarding
Yeah.
like conditional joint probability.
Conditional joint probability. Okay.
Yeah.
Yeah.
Because, example, if I have probability of B given AC.
Probability of B given A comma C. Yeah.
Yeah, given A comma C.
Yeah.
So how can I change it to probability of B? Probability of C given AB.
You want to change to probability of C given AB.
Yeah. So the
Okay.
condition should be only with respect to AB and not AC.
Okay. So this is correct, right? I am just breaking this up. A B of A comma C, that is the definition of
Yes,
conditional
yes, sir.
distribution, conditional probability. So okay, tell me once again what you want. You want AB, C by AB.
Yes, sir. C by AB.
Okay, so
So whenever there is only two variables, that condition it's simple. But when it comes like this joint condition, it is little complex, sir. How to?
yeah. So I also I mean, I don't know whether I will be able to solve this, but okay, let me try. So P of ABC by P of AB. Correct. Okay. I have P of B given A comma C. Okay. So you can do one thing, P of C given AB into P of AB equal to P of B given A comma C into P of AC. So P of C given AB equal to P of B given AC into P of AC by yeah. Have you been given any other thing to solve, or just what do you, I mean, what form do you want your answer in? That
So
is,
there was one formula, sir. I couldn't follow how it came. Like probability of B given AC is equal to probability of BC given A divided by probability of C.
can you tell me once again, probability of B given AC?
Given AC
Huh?
is equal to probability of
Huh?
BC given A
Huh?
divided by probability of C.
With no independence assumptions.
No, no, sir. Nothing like that. No independence assumptions. Just using simple Bayes theorem.
Okay, so you want to prove this, is it?
Yes, sir.
Okay. ABC by PC. A and C are not independent of each other. You are sure of that?
Yes, sir.
Okay. BC by A by PC. Okay. Now I can write this as okay, I can write this as P of ABC into P of AC by P of A, P of C into P of AC, and this I can write as P of B given AC. Okay, yeah, this can be done. Yeah. So okay, let me just do this. Okay, this is 1. P of BC given A by PC is equal to P of ABC. Okay, this is 1, and P of B given AC is P of ABC. No, by P of AC. Can you check once again whether A and C are independent of each other? Because it seems like, if for example you have said B of AC, B given AC, okay, B given AC is this, okay, ABC by P of AC, this is given, and the other condition is P of BC given A by PC, so BC given A by PC is this. So when you equate them, I mean, you have already said that these two are equal, so when you equate 1 and 2, P of ABC gets cancelled, that leaves P of AC equal to P of A into P of C.
Okay, so in that case, they are assuming that they are independent, A and C are independent.
I think so. I think so. Can you tell where you have got this?
So I've seen somewhere, so I don't remember because I was referring to.
Okay, I think they are independent, but okay, I'll try also, but I think they are independent. A and C should be independent, only then you can write this.
Okay, because sometimes if they give like how to change those conditions, sir, that is where I am having like tough time. So in case if like example P of B given AC, now that condition should be changed only with respect to given A or given AB. So how can I?
That you can do provided you have some independence conditions in your hand. I mean, otherwise it might become very difficult, or it might not help you also in such cases. I mean, in for example, in this case, if P and if A and C are independent of each other, okay, then what you can do is, for example, suppose you know that A and C are independent of each other, then what you can do is, the first thing that I always go about doing is write it in the main form. Okay, now once you write it in this form, then what you can do, ABC you cannot break because A and C are independent, but you can always do this.
Okay.
Right, you can always do this. And now yeah, so this P of ABC, so suppose you want only C to remain in your condition, so P of ABC, what you can write is P of so let's say you write P of, you only want C, right? So you write P of AB given C into P of C.
Okay.
Okay, that ABC remains by C remains, okay, by PA into PC, PC gets cancelled, and therefore I mean P of ABC by PA into PC becomes P of AB given C by P of A. Did I make sense? So suppose you had PB of AC, that you found out to be P of AB given C by P of A. So here you can say that P of AB given C equal to P of A into P of B given AC. So I would suggest that don't get into those formulas, you will get more and more confused. So I would always say that whenever you see such formulas, you break it up into the proper, you break it up in here, and then you see whether some independence, something helps you somewhere.
Okay, but can you explain once, sir? How did you derive that this?
Oh, okay. See, so what you told me was BC. What you told me was B given AC, right? You told me this, and you said that okay, now I have to find a situation where only I condition on either A or C. Now let's say I condition only on C.
Okay.
So the first, and provided A and C are independent, so what you are doing is you are just using the formula for joint of conditional distribution of conditional probability, and you are getting P of B given AC equal to P of ABC by P of AC.
Okay.
This is fine. Now since you have been told that A and C are independent of each other, you can always do this, correct?
Okay. Yes, sir.
Now the next step is you wanted to condition on C.
Yes, sir.
So A and B has to come on the other side and C has to go to the conditioning side. Okay, this is fine.
Yes, sir.
P of A into P of C. ABC I have broken down as AB given C into P of C.
Got it, sir.
Now you cancel C and you get the formula.
Okay. Okay, sir. Thank you, sir.
Yeah. Any more questions?
I have one question on eigenvalue last.
Yeah.
Sir,
Yeah.
but if might be I will go last, sir, in case if somebody has questions of this week.
Okay. Yeah, you can go ahead. I don't think anybody else has any questions. Yeah.
Sir, last week, like in your lecture, sir, you were mentioning about eigenvalues. You said only square matrices have eigenvalues. You
Yes.
mentioned this point.
Yes. Yes.
So I wasn't clear, sir, why only square matrices will have eigenvalues.
Okay, that's a very good question. Okay. Okay. Let me try to explain this. I am taking a rectangular matrix. Okay. Yeah. This is what? A 2 cross 3 matrix. I am multiplying it with a vector of 1 0 0. It will give me 2 3. Is this clear?
Yes, sir.
Okay. Now, given that you have this definition, I mean given that you saw this example, now tell me, this is the definition of the eigenvalue, correct?
Yes, sir.
Now this is a scalar, this is a vector, this is a matrix, this is the same vector.
Okay.
So what will be the dimension of this on the what will be the dimension of this V and this V? Let's say this V is R3. It's a 3-dimensional vector. What will be the dimension of this V? It's the same V.
Same, sir.
It's R3, right? So what will be the dimension on the right hand side?
R3 only, sir.
R3. So now see this. This is R3. This is R2. Correct?
Yes, sir.
So basically what happens is somebody is saying A minus lambda is meaningful only for A being square. All those are correct. Those are all definitions of the eigenvalues. Actually I wanted to, I am telling you this from a more geometrical point of view. So what is happening is, you have a vector V, okay, you pass it through this matrix A, that becomes lambda V. This dimension and this dimension cannot change. That is the definition of eigenvalue. Here, if your matrix becomes rectangular, then this dimension and this dimension has to change. As you saw here, it went from R3 to R2. Is it I mean, is it clear?
Yes, sir, but okay, so it should not change. Okay, got it.
So if you have a definition like AV equal to lambda V, and this V and this V is the same, then these dimensions must be same, right? This dimension should be the same as AV.
Okay.
But whenever you are multiplying with a rectangular matrix, this dimension is not same as this dimension. You are going to R2 from R3.
Okay.
So that is a simple way of putting it. The other way of putting it is, you can see that, for example, I mean this is a more geometrical viewpoint. So suppose you have so when you are doing this operation AV equal to lambda V, all you are doing is you are scaling the vector, correct? You are scaling the vector by lambda times.
Right, sir.
And when this becomes a rectangular matrix, A becomes a rectangular matrix, then you are actually going from, let's say, some vector space dimension M to some vector space dimension N, where M is not equal to N.
Yeah.
By scaling operation, you cannot change the plane of a vector. just by going along the same direction of the vector, you cannot go from, let's say you are in the R2 space, you are going in the xy plane, all of a sudden just by scaling a vector on the xy plane, you cannot move it to a 3 dimensions, you cannot move it to the 3 dimensions, correct. While when you are scaling, you will always stay in the same plane, you cannot move out of that plane. So
Okay, got it, sir.
yeah, so that is the geometrical reason as to why a rectangular matrix cannot have a eigenvalue. And the easier way of understanding this is, as somebody is saying, is this is the determinant of A minus lambda I. So determinant of A minus lambda I, so this is a square matrix, I is always a square matrix. If A is not square, this, I mean, you cannot subtract two matrices with different dimensions.
Okay.
So that is why it is not possible. Good question, yeah. Okay, if there are no more questions, I'll stop the session, and we'll meet again next Tuesday same time. Thank you.
Thank you, sir.